All right. Thank you, Dr. Hezzy, for everything. Just going to be talking about week 6 assignment. We're going to be going over the PowerPoint presentation that we have put together right here. Basically, just talking about the understanding of Singleton classes, conceptually, application, kind of the whys, the implementations, and understanding the key concepts of everything going on in the couple of lectures that we've had so far. I would go over to slideshow. So starting from the current slide, obviously this recording took place today. Switch to the introduction slide. So ultimately, why are we using Singleton classes? A Singleton class is a design pattern that restricts the instructions of a class to one single instance. This is really important because Singleton classes are essentially for several reasons. First, they help manage resources effectively, ensuring that only one instance of a resource manager exists. By basically handling the system handlers of a database connection pool, this is important because it overall avoids unnecessary duplication and potential data inconsistencies. When you have your code, you don't want that because you want people to replicate your data and replicate your code and easily comment out certain instances like this. But with duplicates, it becomes messy. And anytime we're writing code, you want it to be clean and flow and be able to retract your steps and pass it on to somebody else so that they could continue on with a different class. And the Singleton class does this very effectively. And overall, it provides a point of class and enhances security and integrity by preventing unintended modifications. You could basically see this in the real world applications by numerous different ways, considering manager applications, as I said before. You want to be able to log your code and have someone replicate it and understand it, test it, debug it, analyze it, and implement it. So by implementing this Singleton class, we ensure that basically the configuration settings are loaded once and uniformly across the platform or application. Another example of such is a logger, which might aggregate logs from various parts of an application into a single log file. Another application would be a database connection pool, which is basically a classical Singleton use case. You don't see it too much in the real world anymore, but you do see it every once in a while. Basically managing connections efficiently and providing them on demand to different parts of the application. Now we will switch over to the advantages. So what are key kind of advantages to why we would use Singleton? Class is basically offers reduced memory footprint. As we talked before, memory is crucial, especially when you're kind of going over databases and going over the use of infrastructure. So basically it eliminates multiple instances of a class that essentially performs the same. So it basically makes it better perform and easier maintenance. Additionally, Singleton classes basically provide global access, which is important because when we write code, we want it to be implemented across internationally and in-house. And when you write code, you want your company to use it as a staple in multiple different demographics. So we'll switch over to designing. Why do we design it and how can we design it in Java? So basically the way we would go about designing a Singleton class in Java would be to have it in 3 key steps by making the constructor private to prevent external implementations and creating a private static instance in the class and providing a public static that returns the instance of the class. This method ensures initialize Singleton and kind of show you how the infrastructure and how everything works. Just basically an implementation of a private constructor and a static method generator in the get instance. This method checks if instance is null. If so, it basically makes a Singleton class not. If simply returns the instance, then ensures that the only instance of the class is ever created and accessible globally. And this is just overview that I already went over in simple terms, just kind of dumbing it down. And then we wanted to go over one that illustrates basically a word count program. And this is crucial because it shows a conversion from a simple Singleton class to one that is used on a more implementable way in a word count manager. So this is basically the one that I came up with, and it basically uses a private constructor again. And instead, it synchronizes a method to add words to count, ensuring thread safety. The get instance method guarantees that only one instance is managed, and that the application then applies a singleton pattern to manage shared resources basically effectively. And here's a second portion that kind of shows you the word count and the algorithm that goes with it. Simple enough. You have a word. No word exists without a character, so you want to add an integer 1. So every integer above 1 would add a word. Otherwise, you would avoid it out because obviously no word exists without a character. So basically, there's just a conclusion, wrapping it up. Yep. And that'll be it. I appreciate you, Dr. Hezzy, and thank you for everything. Hopefully you enjoyed this presentation, and I appreciate the help understanding the material. God bless.